Okay, so today I'm going to be talking about water and trying to get this. So let's start with what is it? H2O is how we recognize water. So here are two hydrogens and our one oxygen. These funky symbols here is a lambda. It denotes partial charges. And oxygen is extremely electronegative, and so it pulls the electrons from the hydrogens in this covalent bond, making this slightly positive or slightly negative and slightly positive, forming a polar covalent bond. You can also see water written as HOH when you're dealing with acids and bases and in a double replacement reaction. Water has a lot of properties due to these partial charges, so first I'm going to look at its properties as a solvent. So here I have some NaCl. And so what water does, it's really good at dissolving. This is just table salt. And so what'll happen is, that's not how it'll go. It'll go like that. So waters form around it like this, and it takes, and I haven't broken these apart yet. And so water will form around it, like around the two ions like this. And I wanted to leave them connected because it takes energy to break bonds. So I'm just going to put in some energy here to break the bonds. And then water's going to surround them like this using these partial charges. So the partially charged positive hydrogen is going to be attracted to the negative chlorine, and the negatively charged oxygen is attracted to the sodium. And so what you're going to form is what's called like a hydration barrier. And so because the waters surround it, that's held away, and it pulls them apart. These partial charges also, water is very cohesive and adhesive, and so it likes to bond to themselves, so the partial charges will line up. This is what gives water a high surface tension, and so they'll just line up, negative to positive charges. And then when you draw a hydrogen bond, they're just dots that connect them. And so because it sticks to itself really well, you got surface tension. It sticks to other things really well. Water also has a high specific heat and a high heat of vaporization. So basically when you're trying to evaporate water, you're pulling on these hydrogen bonds. And as far as specific heat goes, when you put energy in, you're going to have to put more energy in to get these shaking around more, because they're kind of holding each other in the same state with these hydrogen bonds. Once again, high heat of vaporization, it's going to take a little bit more energy, and unlike this, when they were just bonded together, it doesn't take as much energy to get them to evaporate, kind of. But the water is going to take a little bit more energy to get that to evaporate because of the hydrogen bonding. Some other stuff about hydrogen bonding is it's in your DNA, and it's what's holding your DNA together. And then the last coolest thing for me is that water has its strongest density at 4 degrees Celsius. And that's because it arranges itself in this V-type pattern. And you have hydrogen bonding that occurs right here in this V shape. And that causes this almost a crystalline structure to occur. And that's why water or ice is less dense, and which is why it floats in its. That's why ice floats in water, because it's less dense. I hope that was helpful.